Hey there, tech enthusiasts and curious minds. Welcome back to What's Next, where we dive deep into the cutting-edge world of technology. Today, we're about to embark on a mind-bending journey into the heart of artificial intelligence. Ever wondered what really makes AI so smart? It's not magic, it's math. That's right, we're pulling back the curtain on the secret language powering every AI breakthrough you've ever heard about. Stick around because by the end of this video, you'll understand how math isn't just a two-litzy engine driving AI's rapid evolution. And trust me, knowing this stuff can set you apart in the future of tech. Whether you're aiming to build the next ChatGPT or just want to stay ahead of the curve, this is knowledge you can't afford to miss. Now, let's get real for a second. Without math, AI would just be a fancy guessing machine. It's the backbone, the secret sauce, the special ingredient that makes artificial intelligence, well, intelligent. We're talking about core concepts like linear algebra, calculus, probability, and statistics. These aren't just dusty old textbook topics, they're the living, breathing heart of every machine learning algorithm out there. Let's break it down, shall we? First up, we've got linear algebra. This is how AI sees the world. Imagine every piece of data as a point in space. Linear algebra gives AI the ability to understand and manipulate these points using vectors and matrices. It's like giving a computer a pair of 3D glasses to view and interact with information. Next, we've got calculus. This is how AI learns and improves itself, one tiny step at a time. It's all about change and optimization. Calculus helps AI figure out the best path forward, adjusting its approach bit by bit until it reaches the optimal solution. It's like teaching a robot to walk by making millions of micro adjustments to its balance and stride. Last but definitely not least, we've got probability and statistics. This dynamic duo teaches AI how to handle uncertainty, make decisions, and spot patterns in chaos. It's what allows AI to say, based on what I've seen before, here's what's most likely to happen next. Without this, AI would be as useful as a magic 8-ball in predicting the future. But enough theory, let's see this math in action. Ever marveled at how your phone can recognize your face to unlock it? That's linear algebra and statistics working together to map out the unique features of your face. Self-driving cars? They're constantly calculating probabilities and making split-second decisions using all three branches of math we just talked about. And those eerily accurate Netflix recommendations? Yep, that's advanced statistics predicting what you'll want to binge watch next. It's not just tech startups either. Giants like Google, OpenAI, and Netflix are using these mathematical models to revolutionize your daily life. Every time you use Google Translate or chat with a virtual assistant, you're interacting with some seriously complex math. Now, I know what some of you might be thinking, but wait, I'm not a math whiz. Don't worry, you don't need to be a genius to grasp the basics. Let's demystify some of those scary-sounding terms with some fun analogies. Take gradient descent, for example. It sounds complicated, but it's really just like trying to find the bottom of a valley while blindfolded. You take small steps, feeling out which direction leads downhill, until you can't go any lower. That's how AI algorithms find the best solutions to problems. Or how about eigenvectors? Think of these as the skeleton of a dataset, the core directions that define its shape. It's like finding the main supporting beams in a building and Bayesian inference. It's just a fancy way of saying updating what you believe based on new evidence, like how you might change your mind about liking a new food after trying it a few times. See, if you can handle pizza slices and road maps, you can grasp these concepts. It's all about breaking down the complex into simple, relatable ideas. Now, let's boil all this down to a simple formula. Data plus math plus computing power equals AI magic. It's that straightforward, yet infinitely complex in its applications. And here's the kicker, tweaking the math tweaks the outcome. That's why top AI researchers are always chasing new mathematical insights. A slight improvement in an algorithm can lead to massive leaps in AI capability. So why should you care about all this? Well, for starters, math is the #1 skill AI companies are hiring for right now. If you're looking to future-proof your career, understanding these concepts gives you a massive advantage. But even if you're not planning on becoming an AI researcher, this knowledge is power. It helps you understand the technology shaping our world, make informed decisions, and maybe even come up with the next big idea that changes everything. Before we wrap up, let's do a quick recap. We've seen how linear algebra helps AI understand data, how calculus drives learning and optimization, and how probability and statistics enable decision-making in uncertain conditions. We've explored real-world applications, from face recognition to content recommendations, and demystified some of the jargon that makes AI seem so intimidating. Remember, in the world of AI, math isn't just a subject, it's the secret sauce. It's the language that turns lines of code into intelligent systems capable of amazing feats. And now, you're in on the secret. If you found this peek behind the AI curtain fascinating, smash that like button. We want to know what you think. What math concept do you want us to decode next? Drop your suggestions in the comments below. And hey, if you want to stay ahead of the curve and get more future-ready knowledge drops, hit that subscribe button and join the What's Next community. We're always exploring the cutting edge of tech, and we want you along for the ride. As we sign off, remember this: in a world increasingly driven by AI, understanding its foundations isn't just interesting, it's essential. Stay curious, stay ahead, and most importantly, stay with What's Next. Until next time, keep questioning, keep learning, and keep pushing the boundaries of what's possible. The future is math, and the future is now. See you in the next video.